So now everything is stored in the cloud. We actually need some efficient way to access the dataset and also do the computation, because traditional desktop computing is just not going to be able to handle this kind of datasets.
Welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the geospatial community. My guest on the show today is Qiusheng Wu. He is an assistant professor in the Department of Geography at the University of Tennessee. And today on the podcast, we're going to be talking about Google Earth Engine. Just a quick message from me before we get started today. A couple of weeks ago, I asked the people on a mailing list if they would be interested in spending half an hour with me, just getting on a call and letting me know what they're working on, what they're struggling with, where they are in their careers. And so there was a very selfish reason why I did this. I wanted to understand who was listening so I could find out how to make the podcast better. And it was really inspiring to get the opportunity to talk to so many of you. So for those of you that took the time to speak with me, to spend 20 minutes with me, thank you very much. I really appreciate it. You've helped me more than you know. So this was a fun little experiment just to see if anybody would, take me up on the offer, I guess, would spend the time with me. And lots did. So I'm going to do this more often. So if this is something that you might like to be involved with, go to our website, mapscaping.com. You'll see an email sign-up thingy there on top of every blog post for the podcast. Jump on that and hopefully we'll get a chance to talk soon. Okay, that's it from me. Let's dive into the interview. Let's talk about Google Earth Engine. Qiusheng, welcome to the podcast. I'm really looking forward to this. You are doing some really amazing work with Google Earth Engine, and that's what we're going to be focusing on today. But I think before we dive into that, perhaps you could just let the listeners know who you are and how you got involved using Google Earth Engine.
Daniel, thank you very much for having me. I'm Qiusheng Wu. I'm an assistant professor in the Department of Geography at the University of Tennessee. And so my research focuses on GIS and remote sensing and cloud computing. I started using Google's engine, I think back in 2017. And so after that, I have been using that for most of my research and teaching. And starting last year, I started developing a Python package called Gmap, and it has been widely used by the Google Earth Engine community, and I'm still actively developing the package and contribute to the geospatial open source community.
And that's how I found you, through the work you're doing with Gmap, and that's GEE map. And it's a Python package, and I really want to talk about that a little bit more later on. But could you just sort of briefly describe what is Google Earth Engine?
Google Earth Engine is a cloud computing platform for scientific analysis and visualization of geospatial dataset. It's free for research, education, and non-profit use. I can give you an analogy so that you can better understand what Google Earth Engine it is. For example, in the past, before we actually have, for example, the streaming services like Netflix and Amazon Prime, right? How did you watch a movie when you want to watch a movie? So you can either go to the movie theater, or maybe you can buy a DVD from the store or from online, right? For example, after you have the DVD, you need to basically on your computer have a DVD-ROM or Blu-ray that actually can read the DVD and you can start watching the video, right? So this is like traditional, it's similar to the traditional remote sensing. So when we need to do some project, you need to basically go online to different agencies to download the remote sensing data set, and you need to do some geoprocessing, and after that you need to actually to have some professional software that just like ArcGIS or MV or others to load the dataset, do geoprocessing, and get the results. But right now, if you watch a movie, right, using streaming services, Netflix, you just need a browser and some kind of internet connection. Then you will be able to stream movie online without having to worry about the DVD or loading the DVD, playing the DVD. You just need a browser. So Google Earth Engine essentially is the same. Now, you don't need to go online to download the data. You just need a browser, and you can access to the entire Google Earth Engine data catalog without having to download anything. It also has a bunch of tools for you to do analysis and visualization. So, for example, you can extract some features from the imagery using the traditional remote sensing. You need to do a lot of work actually to extract. But right now, using Google Earth Engine is very easy. You just need to have a bunch of filters. You can have some algorithm, and at the end, you can do some very, very cool analysis without having to worry about the data storage and also the computing power. And it's free. So it's going to save you a tons of time without having to download dataset and do some pre-processing, because most of the dataset within the Earth Engine data catalog is analysis ready. So you can use it for us for analysis. And right now, I think it has more than 35 petabyte of data. So 1 petabyte is 1,000 terabytes. So 35,000 terabyte of data. And you can access that using a browser. It's going to be a huge time saver for your research and teaching.
Thank you very much for that. I feel like we jumped in really, really deep there, though. So we're talking about this incredible product, Google Earth Engine. It's got this massive data catalog. It's got a lot of analysis built into the system that we can take advantage of it. You even mentioned analysis-ready data. And I think perhaps we should start there. What kind of data are we talking about? So you mentioned remote sensing. I'm assuming that we're talking about pixel data. Is that correct?
Yes, it actually not just pixel data, it also have some vector data, so geospatial data set. So now most of the common satellite, for example, Landsat, Sentinel, MODIS, and also all kind of land use, land cover data, weather and climate. Also some vector data, for example, polygons and census data, for example, in the US. They're local products and you can, so for data set that's not available within the public data catalog, users can also upload the data to their account. So each account has 250 gigabyte of storage. So you can upload your private data or some commercial data that only belongs to you. And it won't be public until you change it to be public. So you can use that to utilize the parallel computing within the Google Earth Engine platform to process your own data set.
Okay, we're talking about getting access to it now. How do we get access to it? What do we need in order to be able to make use of this platform?
You just need to go to the Google Earth Engine website. I think it's earthengine.google.com. And then you need to sign up using your Gmail account. So if you have an university edu email address, usually I think the approval is instant. But if you have some like a regular Gmail, it might take some time because they need to verify your status. So, but usually it's just a couple of days. You should get approved. Once you approve the account, then you can log in to the Google Earth Engine platform. It has a so-called Google Earth Engine JavaScript code editor. So that one is basically the JavaScript API. And then you can start writing JavaScript and analyzing the dataset and also visualize the datasets.
Okay, so we've got, once we get access to the platform, there's a huge amount of data already in there. We can upload our own data to the platform and we can manipulate that data using this JavaScript API that you're talking about, or JavaScript user interface.
Exactly.
How do I go about filtering the data, for example? Because I'm thinking it's one thing to have access to a massive amount of data. How do I find the data that I'm interested in?
So the Google Earth Engine, the website, the interface, they have a specific section called datasets. So within the dataset, you can search any data you want, and it's going to give you a list of datasets. Then you can select from there. Also within the JavaScript code editor, there is also a search box you can search, and then you can just use one click to import the dataset to the code editor. So basically, within the Google's Engine data catalog, each dataset has a unique ID. Just think about like each individual person, like we have a name or social security number. So think about in the entire world, we have countries, and within the countries, we have each individual person. So similarly, in the Google's Engine, it has so-called image collection. So image collection is basically a stack of images or time series images, just like similar to a country. So within the country, you have each individual person. So it's a hierarchical structure. They say Landsat 8, right? So Landsat 8 is a sensor. So within the Landsat 8, you also have multiple products. You have the raw data. You have also have a surface reflectance, right? So when the surface reflectance itself is an image collection, and within the image collection, you have a bunch of images, just like a folder on your computer. And within the folder, you have each individual geotiff, and each geotiff has a unique ID. So when you are trying to filter the image, for example, if you want to find out the image for the US, you just need to say, okay, I want the Landsat surface reflectance dataset. That one has a unique ID, so it will be e.image collection, and then the parentheses, and then you put the ID in there, and then you can use this one as like a kind of the parent, and then you can do the filter. So dot filter by date, by location. You can also filter by metadata. For example, if you just want cloud cover less than 10% or 5%, whatever criteria you want to use, and then you just continue step by step to do the filter. Usually, you just need maybe 3 or 4 lines of code, and then you'll be able to get the data set that you want. Compared to in the past, you need to go online, you need to download the data set, And sometimes you might end up like, oh, I download the wrong data set, the wrong date, or maybe the wrong location. Then you need to go over and over again. But in Google's engine, if something goes wrong, you just change the code and then you run, you get the result instantly. So it's going to save you tons of time.
Earlier in the conversation, I believe you said that this data was analysis ready. Does that mean that a lot of this Earth observation data has had atmospheric corrections applied to it, that it's cleaned?
Yes, for example, for the most common one, Landsat and Sentinel. So all those data sets, each sensor, they have multiple image collection. So they have the raw data. If you want to apply atmospheric correction by yourself, you can do that. But they also have some other data product called top of atmosphere and also surface reflectance and also some derived data set. For example, normalized difference vegetation index or normalized difference water index. They have a bunch of derived products. So you have different level. It depends on your specific application requirement. You can use the raw data set. You can use those analysis ready data set. You just need to search and find the exact data set you want.
Okay, so it sounds like there's a lot of functionality for searching this data set. We can search the metadata, we can search by sensor. I know we can search by geographic location. Let's assume we can easily find the data we need. What kind of functionality is built into this JavaScript interface? Can I do machine learning in there, for example?
Yes, so it has a couple of machine learning algorithms. For example, the traditional one, random forest, decision tree, support vector machine. They have most, I think right now, maybe 7 or 8 kind of a machine learning algorithms that you can do image classification. But they also have some unsupervised, for example, clustering, so X-means or K-means. You can use those just like the same you are doing traditionally using other remote sensing software packages to do classification. And like I said, the advantage of Google's engine is that the scale doesn't really matter. So once you figure out your methodology, you can easily apply to the entire globe without having to worry about the limitation. So and the procedure pretty much is the same. They say you are doing the land use land cover classification for the US, and once you have a good algorithm design, you can apply to any other country or the entire globe or continental. So you can basically do global scale, regional scale, or local scale. Depends on your specific project, but all you need to do is just to change the ROI. So or the date. Like I said, when you do the filtering, image collection filtering, you can filter by date, you can filter by location, and the algorithm itself can pretty much remain the same. And you can run the algorithm for anywhere. So this is one of the huge advantage, and you get the result pretty much instantly without having to, if you use traditional remote sensing, you need to re-download the dataset for other location, and then you need to do some analysis. Sometimes it might take, for example, a couple of days or a couple of weeks before you can get a product. And sometimes you might end up like, oh, something goes wrong or a parameter is not set correctly. You need to rerun the analysis, and then you take maybe another couple of days or weeks. But in Google's engine, just within minutes, you can change the settings. You can get the result just within a few seconds, and that's it. So it's going to save you tons of time if you tried it out.
I just want to make sure I've understood this correctly. It sounds like you said that I can do my testing at a global scale, because I think traditionally, if I was doing this kind of analysis, I would, have a sample set, a specific geographic area that I'd work on. I would, over time, I would improve my algorithm. And then once it was at a stage where I was happy with it, I would sort of release it on a global scale. But I think I heard you say that I could test my algorithm on a global scale. How is that possible?
When Google Earth Engine is running the computation, it does not run, for example, on the native resolution. They say Landsat they has 30-meter resolution, right? It's not running the computation on 30-meter resolution. It runs the computation based on the map display, the data display on the map, and also the zoom level. So if you only look at the on overview at the globe, it's probably computed in kilometers, tens of kilometers. And when you zoom in, you get a high resolution. But keep in mind, the map view also becomes smaller. So it only compute a small pieces. And behind the scene, there are tens of thousands of Google Earth Engine servers actually run the computation. So it actually subdivide the data into small pieces and send one piece to each individual server, then run the computation and then send back the result, aggregate the result, and then display on the browser. That's why it's so computationally efficient. And it doesn't matter whether you're doing global scale or a regional scale, the algorithm behind the scene is pretty much the same.
I understand that when we're doing computation like this on pixels, it can be a lot easier to run that in parallel because, a pixels, I can send a stack of pixels to a server or to a graphics processor and say, here, do this job and do this job. It's easy to divide the tasks up. But what happens if we start introducing geometries to this? Or if there's overlap in the pixels, or if we're doing computation around a neighborhood, for example?
That's a good question. And that's also one of the challenges of Google's engine. It's best suited for doing pixel-based analysis. You can certainly also involve some neighborhood. Google's engine has some functionality for doing, for example, convolution or reduce the neighborhood. For example, you want to do it by 3 by 3 or 5 by 5 or 7 by 7, whatever. But you don't want to go too far away because when a pixel is related to something far away, it's very difficult to actually do the parallel to subdivide into small pieces. And this is especially true if you're dealing with vector data. So vector data, because it's, for example, one big polygon, you cannot really subdivide. So it's cannot be efficiently used for parallel processing. But nevertheless, Google Earth Engine still have some capability for dealing with vector data, but it just, the limitation is relatively compared to the image, it's high limitation. So if your polygon has tons of vertices, most likely it's going to run into memory issue because, like I said, when you have the polygon, it's difficult to subdivide. So sometimes you need to put the entire polygon or all the vertices into the same server. And the memory, if it runs out, and then your computation stops, and then you need to figure out like what's wrong. So there are some like best practices you can follow in order to avoid this kind of memory issue. Google Earth Engine, their documentation is very comprehensive, and they have a specific section teach you how to follow the best practice, how to avoid this kind of computation memory issue.
So Google has another huge vector engine called Big Query GIS. Is there any integration between these two platforms, between Google Earth Engine and Big Query GIS?
So this one, BigQuery, I'm not quite familiar, but I think behind the scenes, the Google Earth engines, they might be also using some kind of technology between the two, but it's not officially documented on the Google Earth Engine website yet. It has mentioned nothing about the BigQuery GIS, but I assume, for example, Google Earth Engine, and BigQuery GIS, they might somehow behind, they might have some integration, but they have not released yet. Let me give you an example. For example, Google Earth, right? You see when you go on Google Earth to view the satellite imagery, you see a lot of imagery. You don't really see cloud unless you are viewing some MODIS data, for example, coast resolution. But when you zoom in to city level, street level, you see the image is pretty nice. Some of those are come from commercial imagery, but there are also a lot of imagery come from, for example, Landsat satellite sensors. And if it is cloud-free, they're actually not real. Some of those data sets actually are being processed by the Google Earth engine to create cloud-free mosaic, and then Google Earth actually pull the data set from the Google Earth engine data catalog.
I guess what you're getting at there is that there is integration between Google Earth Engine and other Google products. So probably there's something going on behind the scenes when we think about Google Earth Engine and BigQuery GIS. I want to get back to this idea of running Earth observation and analysis now, because traditionally what you do is you download some data like what we were talking about before. We'd run it through a specific process, and possibly during that process we would create a lot of intermediate results that we might want to save somewhere and do something with later on. Or we definitely have an end result. Can we save these intermediate results in Google Earth Engine, or can I export the end result to something else?
Yes, so Google Earth engine, you can do on the computation. If you want to save the result, there are a couple of ways you can do that. So the first way is you can save to your Google Drive. So it has some functionality that allow you to export the data. So you can export data to Google Drive. And the second one is to your Google Earth engine account. As I mentioned earlier, each account has 250 gigabyte. But you need to understand the differences between different export locations. So if you export data to your Google Drive, you can then download data from your Google Drive to your computer. But if things get into Google Drive, it becomes a regular data set. It's no longer a cloud data set. So it's not optimized for parallel processing. But if you export data to your Google Earth Engine account, it stays in your account. That one is cloud data set. So it's similar to any other data set in the Google Earth Engine data catalog. They are analysis ready. So you can directly use that to pull the data set into your script to do computation. But if you export to Google Drive, then you no longer can use that with your Google Earth Engine script. You need to again upload the data to your account, and then it's going to take some time to ingest the data set, because in order to be able to use in the your script, it need to be optimized for parallel processing. So if you just want the end product, you no longer need that for computation, then it's better to export to your Google Drive. If you want to later just intermediate, you need that later for computation, then it's better to export to your Google Earth Engine account. And so the third way is you can use Gmap. So use Gmap, the package, you can export data directly to your local computer. So you can export, for example, some data is raster data as GeoTIFF. You can also export vector data as a SWAP file or GeoJSON directly to your local computer without having to utilize Google Drive.
Okay, so if I export to my Google Earth Engine account, that means that that data, whatever it is that I've created, that is going to be available. That means that it'll be saved in a cloud processing format that Google Earth Engine will understand, and I can use it in other computations. Can I also make that data available to other users of Google Earth Engine? If I create a product that's just amazing, can I say, hey, world, please use this. I've stored it here. This is what it's called.
Yes, you can. The sharing protocol is similar to any other Google product. Just think about like your Google Drive, right? You can share a folder with anyone publicly, or you can share the folder with a group. So same idea in the Google's Engine account. When you export the data, you can create folders within your Google's Engine account. Then you can export, for example, all the data set to a specific folder, and then you can share the folder with a Google group. So if someone is within your email list, you can just add the Google group, and then anyone will be able to access this. You can also share it publicly, so anyone will be able to use the dataset. Then you can share the link with anyone. And the third way that if you really want to make your dataset popular is to actually request the dataset. So if you come up with some fantastic data product, you can actually submit a data request to the Google Earth Engine forum. For example, you can report bugs, but you can also submit feature requests or data requests. And if the data gets popular, it can be adopted by the Google Earth Engine team. So at the end, it will become part of the Google Earth Engine data catalog. So in that way, you get more exposure, and your data set is going to be used by tons of people if it is in the data catalog.
This sounds incredible. So not only do we have this huge data catalog, we can share data between, with other people. If other people are doing research, I can say in the same way we can with Google Drive, for example, share things, give certain people access to certain data sets. I can do my test analysis, I guess, at a global scale and zoom in and see how it's running at a more local scale. I have machine learning algorithms I can use. I've got different interfaces I can get at the data from. It just sounds amazing. Is there anything missing? When you think about Google Earth Engine, what's missing from this piece?
So Google's engine is good for pixel-based analysis, and some of the analysis, for example, for me, I'm doing some kind of hydrological studies. And as I mentioned earlier, when you have a pixel that's related to some other pixels far away, sometimes it's difficult to scale, and it's not good fit for this kind of a parallel processing. So in that way, you might still need some desktop computer actually to do some processing. And if, for example, if my research involves a bunch of steps, some of the steps might be best suited for Google's engine, but some might need to be running using local computer. So the best way, the strategy is to, if something needs your local computer, you do some processing, and then you get the intermediate results. Then you can upload the results to intermediate result to Google's engine, and then you can still utilize Google's engine for some of those steps that can be best suited for parallel computing. So like I said, Google's engine is good, but it cannot do everything that we want. There's certain limitation in its design, but it's still a huge time saver to me because I've been using it, and I used to download a lot of data set from USGS and NASA, but now I just use Google's engine data catalog. At least you can quickly visualize the data set and to do the filtering. The other thing I really like about this is you can also create so-called Earth Engine apps. So think about in the past when we have a journal publications, right? Some people might develop some products, and nowadays we have a lot of so-called open repositories that people can upload the dataset to those open repositories, and people can go online to download the dataset. But still, you will need some professional software actually to view the dataset. But Google's engine, if you develop the algorithm, and at the end you can actually release the data products, you can save that within your Google's engine account, and then can develop a web interface. People will be able to go online and then go to your URL, and then they can visualize the data set. They can also do query. They can click on the map. They can get the pixel values. They can also do filtering. So there are a lot of things you can do using this kind of app. It's very nice for if you really want to make your data public or make it accessible to a wider audience, because anyone can just use a browser to look at your data set, your products, without having to install anything on a computer. So it's going to make it accessible to anyone around the globe.
This has got to be a giant leap forward when we think about reproducible research.
Exactly. So, and this is also something that I'm really have been working on this one because I really want research to be reproducible and transparent. And then Google Search Engine actually takes a big step forward in terms of reproducible and transparency. You can make a source code, so you can share your source code just using one click, and then it will generate a URL. You can send the URL to anyone; they will be able to open the URL and run the source code just like what you did and get the same result. You can also release your products and people can actually build on top of your products. So in this way, we reduce basically repetitivity. So people don't need to like read your paper and then go through step by step trying to reinvent the wheel. People can just take your algorithm, they can improve and they can build on top of your products and then get improving. So in that way, I think human resources are better utilized and then we all work on the same, for example, build on top of the same baseline and then we keep improving rather than like everyone working on their own version of the data set. And at the end, it's very fragmented. So now we have some kind of, for example, centralized data catalog, and we have the products, for example, a lot of, let's say, deforestation, right? We have some global forest data product. We also have some global service data products and have for the past several decades, for example, the service product developed by the European Resource Commission, and it's very that one is very very popular. So and many people actually build on top of that products to improve the algorithm and to come up with some other better products. So in that way, we save time and we always have something to refer to as the baseline, and we keep improving.
Yeah, so in science, we always talk about that standing on the shoulders of giants, and it sounds like this is really going to speed up that process. But would you mind talking to us a little bit about how we do all this stuff? Like before, we mentioned this JavaScript interface. Is that kind of a drag and drop editor, like what we might be used to in some of the other products and some of the desktop products that people are using to do similar analysis, or is it a coding interface?
The JavaScript code editor is essentially a coding interface. So Google Search Engine is not like in traditional software that you can click and drag and drop. It has a bunch of basically a lot of so-called API or functions. So you just need to call each function and then put all the functions together to do some operation. And it has a very comprehensive documentation. So on the Google Search Engine code editor interface, you can also access to each individual function. They also provide a list of basically snippets or sample script. You can learn from those sample scripts, and then you can just run. You can change your settings. You can change the image collection. Also, on the documentation website, they also provide a lot of sample codes, and most of the time it has a button. So the button is like open in code editor. So you just click the button, and then it's open and load the code, and then you'll be able to run the source code, and then to see the result. So this is mostly in the JavaScript. It's good. You need to basically have some basic background in JavaScript in order to be able to use that. It's not like traditional software that everything is just like interface. For example, MV or ArcGIS. It's not like that. So it has learning curve, but once you get used to it, it's very intuitive because you have a lot more control on the data set and also the design. You also know the things behind the scene, because if you're using the click interface, sometimes people don't understand if something goes wrong, you don't know how to fix it. It might be a bug in the software, but in the Google's engine. So it basically you write everything from scratch, or you can build on top of your algorithm from other people's source code. But you can see behind the scene, step by step, which line is doing what, and you can always go back to revise the script. So this is just for the JavaScript, but you also have the Python API. And Google's engine, it can be seen as two components. The first component is doing computation, and the second component is doing visualization, right? So once you want to view the data set, you want to view your result. JavaScript API has these two components, but the Python API mostly is just the computation. So the Python API does not provide functionality for you to visualize the data, visualize the result. And that's why I developed the Gmap Python package. And so Python user will still be able to do things interactively, right? Just like the JavaScript code editor. But I also simplify a lot of things. So eventually, user might be able to just click some buttons and then to do some analysis. You can adjust the parameters using some interactive user interface without having to actually write any line of code. And so that's my goal, is to actually make it easier for people to utilize Google's engine. And even for people without any programming background, they will still be able to use it to do some scientific analysis of geospatial datasets.
What does all this mean? Like, there's so much opportunity here, this massive amount of data. It's connected to possibly the biggest computer in the world. There's different ways of getting at the data. I mean, it's just, and sharing the data, it's just absolutely incredible. But what do you think this means for the future of Earth observation and remote sensing? Could you imagine something like the Google Earth Engine becoming a standard tool, a standard skill that Earth observation scientists need to understand?
Yes, I think right now, at least for the past couple of years, it has getting quite popular. But there are still some concerns about Google Earth Engine because it's not open source. A lot of government agencies, they right now, I think some of them are discouraged to use Google's engine. But for me, people in the academia, I think many people are using that, and it's the overall trend because right now all the environmental problems are getting more and more challenging, and it's not going to be solved by each individual person or each individual group, and people actually working together to actually to solve major global issues. And Google's engine is a fantastic tool because people can work together, they can build on top of each other's work, and then to continue to improve. And also because we have more and more satellite sensors and a lot more data sets, so the volume of the data set is getting much larger compared to like 20 30 years ago, right? So now everything is stored in the cloud. We actually need some efficient way to access the dataset and also do the computation because traditional desktop computing just not going to able to handle this kind of dataset. So we have a lot more upcoming dataset, for example, from NASA, from the European Space Agency. And for a regular researcher, the data, for example, the resolution, spatial resolution getting higher and higher. Landsat is 30 meters, but now we have, for example, planet dataset like 5 meters, so 3 meters. Also, the temporal frequency is also getting much more frequent. So the data volume is increasing, and individual is likely not going to be able to handle that kind of data volume and also computation. So Google Earth Engine is just one example. And I assume there will be some similar data products coming from other companies or from different agencies in the next couple of years. So I'm very excited to see the development in this cloud computing and also in the open source geospatial community.
You mentioned the temporal nature of the data just before, and that's something we haven't touched on. How long does it take before one of the Landsat satellites takes an image and it appears in Google Earth Engine?
I think it's just 1 or 2 days. So mostly, so most of data are being ingested. They have some kind of mechanism behind the scenes. So everything is automatic. So once the data set is acquired by the agency, they might have done something to automate the process. So it's pretty instant, especially for some weather and climate data set. Usually it's maybe just within a couple hours, and then you can access the data set within the Earth Engine data catalog.
That's just incredible. So I'm assuming a lot of this data that you get access to is free and open data. Can I pay extra money and somehow get access to paid products in there as well?
No, I'm aware of. So if you have some paid product, for example, you have some commercial satellite data, for example, from Planet or from World View, you can upload data to your account. But Google Earth Engine itself does not sell data sets. So you need to actually buy the data sets through different vendors and then upload to your account, and then you can keep it private to do computation.
So there's a lot of things here. Is there any one thing that you're most excited about? Like, are you most excited about the scale that you can do your research on? Are you most excited about how easy it is to do it? You just need a browser and some understanding of JavaScript, and you get access to this incredible amount of data and processing power. Are you most excited about the opportunities to create reproducible research? Is there any one thing that really stands out for you when you think about Google Earth Engine?
So for me personally, it greatly benefit my research and teaching. So we used, for example, for teaching students, we need to use loads of commercial software, and especially right now during the pandemic, right? So students need to have a good computer actually to run those kind of software. But now, if you use Google's engine, you just need a browser. You can do it on your laptop. You can do it on even your cell phone. You will still be able to access this kind of a data catalog, and it's going to save me a ton of time without having to worry about setting up the environment for the student. And also personally for me, for my research, I no longer need to download data sets. So I can run everything just in the cloud using a browser. It saved me a ton of time. I also enjoy basically build the, for example, the Gmail package, and then make it easier for other people to use it, because many people, for example, especially those from developing countries, many of those actually won't have access to commercial software packages, but they still have access to some kind of internet. And so they can use Google's engine. They can also use GMap or Jupyter Notebook or Google Colab actually to do some scientific analysis and contribute to solving some of the global challenges that we are facing right now. So I think we are all working together and then use this kind of a very powerful tool that we are not able to do if we, in the past. Without this one, it's just impossible, because we cannot process that kind of data set. We cannot store those kind of data set on our computer. And now you just need a browser. That's it.
Qiusheng, I want to thank you for your time. You have an absolutely incredible YouTube channel where you are teaching people from all over the world how to make use of this technology. I will, of course, put a link to that in the show notes. But is there anywhere else that the listeners can go if they want to reach out to you, or if they want to connect with you and continue this conversation?
Yes, absolutely. So they can follow my, for example, my Twitter, GSWQS. I posted videos, tutorials pretty much daily. I also have the YouTube channel that I make videos. Most of the video actually for my student that I'm teaching here at the University of Tennessee, but I also release the video for anyone that if they're interested in. And they can also follow the GitHub repo, constantly developing the new features. And if they're interested in Gmap or other open source packages, they can find it on my GitHub account. I also have a blog, blog.js hub.org. I also sometimes post some tutorials on the blog. So you can find me, just search my name on the internet. You should be able to find my contact information and social media.
Again, I'll put links to all of those places in the show notes so people can easily find you. Hey, thank you so much for your time. I really appreciate your generosity and coming along and sharing all this knowledge with us. It's much appreciated. Thank you very much.
Thank you very much for talking to me. I really enjoyed the conversation. Thank you.
So I really hope that provided a really good overview of Google Earth Engine if you weren't familiar with it already, and perhaps it answered a few of the questions if you are familiar with Google Earth Engine. Towards the end of the interview, Qiusheng mentioned a lot of different places you could contact him or find out more. So I just want to take a couple of seconds to mention them here, but there will be links to these different resources in the show notes. So I think if you want to reach out to Qiusheng, the best place to start, I think, is perhaps his website. So if you go to wetlands.io, so wetlands.io, or if you're a Twitter user, he's very active on Twitter, and if you go to look for the account that's called GISWQS, those are two really good places to start. During the conversation, I mentioned something called Big Query GIS. So this is Google's vector version of the Google Earth Engine. So if you're interested in this kind of stuff, cloud computing, it might be worth checking out a podcast episode I published back in July 29th, 2020, all about Big Query GIS. I'll also put a link to that in the show notes just to make it a little bit easier for you to find. And that's it for another episode of the Mapscaping podcast. Thank you so much for tuning in again this week. It's much appreciated. As always, you're more than welcome to reach out to me on social media. I'm most active on Twitter and LinkedIn. You can also email me at info@mapscaping.com. I would really love to hear from you. Okay, that's it from me. We'll talk again next week. Bye.